Hi guys. I'm gonna wait a second. I just wanted to tell you to start with that I decided I'm just gonna start wearing all my math shirts so that I would normally be wearing to school, but obviously I can't. So today I'm wearing the one I would have wore for St. Patrick's Day. So it says math teacher like a regular girl, except luckier. Has a big four-leaf clover. It's kind of cool. Anyway, I did wear it on St. Patrick's Day, but you didn't see me. So anyway, so today we're going to start with chapter 7. So we're going to start with some new stuff that we haven't looked at prior to today. Trigonometric functions. You did cover this in geometry, but I'm going to treat it as if you don't remember anything. I'm going to go over everything as if you haven't seen it before. So we're going to talk about triangles and all those things that you learned again. So I do have the chat up and running. I think it should work. So if you have a question at any point, I'll try to watch it. So there you go. So we're going to start just by talking about a right triangle. Trig is the study of right triangles specifically. So if this is my right triangle, we always label the two sides legs. And then across, so you can think of it of one of two things, the longest side. Sometimes that's hard to tell in a drawing which one's the longest side. There should be a right triangle, little square, and think of that as pointing at the hypotenuse. So this side over here would be the hypotenuse. Now, if you're given a diagram, you should have an angle labeled in there with a little theta symbol. This little symbol is called theta, and it is a Greek symbol. And we just use it like X. It doesn't matter. Uh, it's just a letter like X. So don't think of it as anything complicated. It's not super confusing. So then from the angle, you label the legs as either adjacent or opposite. But picture yourself like standing right here. This is me. Let's draw a little person there. That's me. If I'm standing right there, which leg is adjacent? Adjacent meaning next to, and then opposite is across from. So across from is over here. This side is opposite. And then right next to this side is adjacent. So again, adjacent meaning right next to me, and then opposite across from. Okay, so once you have decided which side is adjacent, which side is opposite, the sine and the cosine and the tangent are the three basic trig functions: sine, cosine, tangent. I'm not going to write out their full name. I'm going to use their abbreviation. So sine is the opposite side over the hypotenuse. Cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. It's always going to be a ratio of numbers. So if I had the side lengths on my triangle, I would just write that as a fraction. This number over that number, or this number over that number, depending on which ratio you're talking about. If you have heard the SOHCAHTOA, that sounds weird, but you may have heard it before. So representing sine, opposite over hypotenuse. Ka representing cosine, adjacent over hypotenuse. So the first letter in each of those, and then TOA, 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 opposite over adjacent. I'm going to erase this. Well, actually, I'll leave it there for a second. We are actually going to cover the other reciprocal trig functions today. I don't know if you covered them when you did geometry. So the reciprocal of sine is cosecant. And so reciprocal just means flip it over, right? So the hypotenuse would go on the top and the opposite would go on the bottom. I'm going to write out cosecant. So you don't want to say CSC. Don't read the abbreviation. Read the name. That's just the abbreviation for the name. So sine, cosine, tangent, cosecant. Secant is the reciprocal of cosine, so it would be hypotenuse over adjacent, and then let me write that out, secant. And then cotangent is the reciprocal of tangent, so adjacent over opposite. So those are the 6 trig functions all together, all 6 of them. These 3 are what we call the reciprocal functions. That's not going to fit there. Let me erase that. So the sine and the cosecant are reciprocals. The cosine and the secant are reciprocals. The tangent and the cotangent are reciprocals. It's easy to remember that cotangent goes with tangent. The secant and the cosecant, to me, are backwards. So if sine and cosine, you would think that cosine would go with cosecant, but it doesn't. So think of this as the S is paired with the C and the S is paired with the C, or the secant is backwards from what you think it should be. Okay, so those are the 6 trig functions. We're going to go ahead and use them now. We're going to go ahead and find all 6 trig functions for a given triangle. So I'm going to erase all this. Also, this notes is posted in Canvas. The notes I would have written out for you are posted in Canvas, so you can go ahead and reference them there. So I'm going to give you this triangle. They will have labeled a little angle for you, theta, and then they'll give you at least 2 of the sides on this first part. So then your job is to decide what pieces do you have and how do you find the third piece. So this is clearly the hypotenuse. Oh, I forgot my little right triangle square. That's the hypotenuse right there because it's across longest, whichever way you want to think about it. So then the 8, is that adjacent or is it opposite? So again, think of you standing here where the little theta symbol is the 8 next to the angle, the symbol, or is it across from? It's across from, so this side is the side opposite. And then how do we find the third piece? Well, there's the Pythagorean theorem works for every right triangle. That's a squared plus b squared equals c squared. And then it doesn't matter which one, where you plug the 8. You can plug it in for the a or the b. Just remember that the c has to be your hypotenuse. So if I put in my 8 here, and then this side over here is my adjacent side. So adjacent side, you could use a letter. It doesn't matter. And then 12 squared. So then I'm going to skip some steps. That's 64 and that's 144. And if I subtract the 64 from both sides, then I get adjacent squared equal to 80. So the adjacent side is equal the square root of 80. Now let's go ahead and simplify the square root of 80. You're going to do your assignment on the Pearson online, and they're probably going to ask you to simplify radicals anytime you can. So 80 is 5 times 16. 16 is the biggest perfect square that goes into 80. And so then the square root of 80 is the same as the square root of 16 and the square root of 5, or 4 square roots of 5. So I'm going to go ahead and use 4 square roots of 5 anytime I plug in for the adjacent side. Okay, so the sine is opposite, which is 8 over hypotenuse, which is 12. Go ahead and simplify that to 2/3. It's always a good idea. Cosine, adjacent over hypotenuse, so 4 square root of 5 over 12. I'm going to go ahead and simplify that. 2 square root of 5 over 3. And then tangent is opposite, so 8. Ooh, I'm running out of room here. Hang on, let me rewrite these a little bit smaller. By the way, I did get ordered a new whiteboard. It's not here yet. So we have this 8 over 12, which is 2/3. Cosine is 4 square roots of 5 over 12, or square root of 5 over 3. And then tangent is 8 over 4 square roots of 5. Now, we need to simplify that to 2 over the square root of 5. But then we can't leave the square root of 5 in the denominator. Correct mathematical etiquette says don't leave the square root in the denominator. So we do something that's called rationalizing the denominator. And it's been a long time since we've done this. So in order to do that, we multiply by a square root of 5, leaving me with 2 square roots of 5 over 5, like so. So that would be the rationalized denominator version of the answer, which I'm assuming the online curriculum will prefer this answer and probably mark that one wrong. Just heads up. Okay. So then we just do our cosecant, which is the reciprocal of sine, and we flip that fraction over. The secant, which is the reciprocal of cosine. When we flip over this fraction, we rationalize it, and it looks like that. And then when we flip over, I'm going to flip over this fraction, right? So it would look like the square root of 5 over 2. I don't want to use this one for my reciprocal. Why? Because that would put the square root back in the denominator, which I don't want, right? So that would create more work for myself. Don't do it. So I reciprocated the one that was 2 over the square root of 5, the simplified but not rationalized version. Okay, so that is if they ask you to find all 6 trig functions for a given triangle. They give you the triangle. Okay, I'm going to erase this. Again, I have posted an online assignment to go with this in Pearson, so you should be able to find that through your Launchpad. Okay, so what if they just give you one of the functions? So the tangent equals 3/5, and they don't give you a picture of a triangle. So you have to figure out what you have. So we know the tangent is opposite over adjacent. And then it might be helpful to draw the triangle. It's up to you. When you draw the triangle, you get to decide where to put your little theta angle. If I put it up here, then my opposite side would be down here, and my adjacent side would be right next to that. So that means the 3 goes over on this side, and the 5 goes there. And then again, we do our a squared plus b squared equals c squared. And then we don't have the hypotenuse, right? That's the piece we're missing. So we're solving for C, and the 3 and the 5 can go whichever, it doesn't matter, in for A and B. So C is equal to the square root of 34, 9 plus 25. And so that's going to go on the hypotenuse of the triangle, right there. And so then when we go to the rest of our 6. So we don't need the tangent. We already have it. Let's do the sine, the cosine, and then the reciprocals. So the sine is opposite. So 3 over the square root of 34. And again, I want to rationalize that. So it looks like that. The cosine is 5 over the square root of 34. And rationalizing it, it looks like 5 square root of 34 over 34. If I could simplify the 3 and the 34, I would go ahead and do that. But 34 is prime, right? Or not prime, but it only goes in, it's only divisible by 2 and 17. And so I can't simplify the 3 and the 34 or the 5 and the 34. So don't even worry about it. So then the cosecant, again, I'm going to use this fraction to create my reciprocal, not the rationalized, right? So it looks like square root of 34 over 3. Secant looks like square root of 34 over 5. And then cotangent is the reciprocal of tangent, so it would be 5/3. Okay, so if they give you one of the trig functions, you might draw a triangle, but definitely need to find the third piece. Figure out what third piece you're missing. Is it the side opposite, the adjacent, or the hypotenuse? In this case, it was the hypotenuse. And then once you have that determined, you just plug in the numbers. Okay. Erasing. There are 2 special right triangles that you will be expected to know and be able to use. The 2 special right, let me go ahead and erase the top here. The 2 special right triangles, again, you might remember this. Are the 45-45 and the 30-60. Okay, so on the 45-45, I could totally explain to you how these are derived and how they come up with. If you want to know how to do that, I would be more than happy to explain that to you. But the 45-45 has a 1, 1, square root of 2. So the legs are the same because the angles are the same. So 45-45 means the legs are the same. And then the hypotenuse, if you calculated a squared plus b squared equals c squared, you come up with the square root of 2. So then the 30, 60, 90 comes from an equilateral triangle that's been cut in half. And so if this side of the equilateral was 2 and I've cut it in half, now that side is 1. And if you solve using your a squared, your Pythagorean theorem, you would get the square root of 3 on that side. So these are the ratios for any 45-45, 30-60-90 right triangle. So if I'm asked for the sine and the cosine of a 45-45 with a leg of 5, what would that look like? Okay, so here's our 45-45. If this leg is 5, then this leg is also 5, right? And then if you calculate your hypotenuse, you get 5 squared plus 5 squared equals c squared. So I get c is equal to the square root of 50, right? And then again, if I have the square root of 50, 50 is 2 times 25. So the square root of 25 is 5 square roots of 2. So that's what I would get for my hypotenuse. Erase this. So that's my hypotenuse. Okay. So then if I'm looking for the sine, which is opposite over, now both of these are 45s, right? So does it matter which one I use as my theta? No, it doesn't. I could use the bottom one and the opposite side would be 5, or I could use the top one and the opposite side would be 5. So either way, I get 5 over 5 square roots of 2, which is 1 square root of 2. And when we rationalize, we get the square root of 2 over 2. Can you see that okay? The same is true for the cosine, right? Because no matter which angle I'm sitting at, my adjacent is going to be a 5. If I'm down here, adjacent is 5. If I'm up here, adjacent also 5. So 5 over 5 square root of 2 simplifies to the square root of 2 over 2. So recommend, draw yourself a picture, figure out what the ratio is. So again, on this one, it's a 1, 1 square root of 2, so 5, 5, 5 square roots of 2. On this one, it's a 1. The hypotenuse is a 2, and the leg next to 30 degrees is square root of 3. On this one, be careful that 1 is always adjacent to 60, and the square root of 3 is always adjacent to 30. So no matter what way you draw it, you could draw it any orientation of that triangle. These two, the 3s are pairs. They should always be adjacent to each other. Okay. And then I have one more example for you. And again, I have these notes posted on Canvas. So if you have a question or if you'd like to look at them, that's where they are there for you. Okay, so this one says the sun shines, it's a word problem application, at 75 degrees with the ground. How long is the shadow of a cactus a 15 feet tall cactus? Okay, I'm gonna draw a really boring kind of. Okay, so there's our cactus. We know the cactus is 15 feet tall, so we'll go like this. Okay, so that's how tall a cactus is, 15 feet. And we're wondering about the shadow of the cactus if the sun shines at 75 degrees to the ground, is what it said. So 75 degrees to the ground is down here. That's what you would call the angle of elevation. inclination, one of those two. So 75 degrees goes here. 15 is the height of the cactus over there. And the shadow, which is what we're looking for, would be on the ground. Makes sense, right? Okay, so then you decide what pieces of information do you have? Well, we have the side opposite, right? This is the side opposite. The hypotenuse would be out here, and then this is the side adjacent. So the piece we need is the side adjacent. So which of our 6 trig functions, now I say 6 trig functions, but you really want to just focus on the basic 3, the sine, the cosine, the tangent. So if I have my tangent equaling opposite over adjacent, then I plug in the stuff I know. I know the angle, so that goes in right here. The 75 degrees, that's our angle, right? Goes in right there. So it looks like the tangent of 75 degrees equals the opposite side, which is 15, over the adjacent side, which is the x that I need. Now, the tangent of 75 degrees, you can calculate that with a calculator, any calculator that has basic trig functions on it. So you should be able to find the tangent button on your calculator and type in tan 75. I don't really know exactly, even your cell phone has it. Let's see. Okay. So I have an iPhone, and mine has it. Can you see? Right here, tan. So if I hit tan, oops, sorry. On the iPhone calculator, I have to go 75 and then hit the tangent button. You should get that number right there. Now it's just a number. I'm not going to write down the number because I want the exact value. So I'm going to solve this equation. The way to solve this equation, if x is in the denominator of the fraction, would be to multiply by x, right? So now I have x times the tangent of 75 on the left side. And on the right side, I have 15. And like I just showed you, the tangent was like 3.7, right? So if I divide that 3.7 from both sides, again, I'm not going to use the number. I'm going to use the exact value. Then I get, so on my cell phone calculator, it's going to be really weird. Okay, so you should get this number, 4.01923, blah, blah. Okay, the way I did it on my, ooh, careful. The way I did it on my calculator, how about if I put the things down? It's like this. So I did the 15 divided by, and then because I have to type in the angle before I hit the tangent button, I would do 75 tangent and then equals. That's how you get the 4.019. And then it said to round to the nearest foot. We're not going to go 4.02. So that would be 4 feet is how big the shadow would be. All right. So that's all I have for you today. Again, like I said, the notes are posted in Canvas, and there is an assignment in Pearson online for you guys to do to practice some of the stuff we covered today. Not a huge, like 10 questions. All right. See you later.